Day 490 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2749, minimum operations to make the integer 0. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two integers nums1 and num2. In one operation, you can choose integer I in the range of 0 and 60 and subtract 2 to the ith power plus num2 from num1. Return the integer denoting the minimum number of operations needed to make num1 equal to 0. If it is impossible to make num1 equal to 0, return -1. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input num1 equals 3, num2 equals -2, our output is 3, meaning it's going to take 3 operations to get this num2 to 0 when we follow these requirements right here. So let's go through the explanation. It says, we can make 3 equal to 0 with the following operations. We choose I equals 2, so that means we're going to do 2 to the ith power, and so we're going to make I 2, so that will be 2 to the second power. Boom, we choose I equals 2 and subtract 2 to the second power plus -2 because num2 is -2 from 3. So that's going to be 3 minus 4 plus -2, which is going to be 2, right? Which is going to give us 1. So this right here is going to give us 2. It's going to be 3 minus 2, which is going to give us 1. Boom. So now we have nums1 is equal to 1. Boom. But we're not done yet because we need nums1 to be equal to 0. So we do another operation following these same requirements. Boom. So now we choose I equals 2 again and subtract 2 to the second power plus -2 from 1. So now once again, we choose I to be 2 again. Num2 is still -2. That doesn't change. And now nums1 is 1. So this is what we're working with. 1 minus 4 plus -2. So once again, 4 plus -2, we're doing PEMDAS. Parentheses come first. So that's going to give us 4 plus -2 is going to be 2. So 1 minus 2 is going to give us -1. So now we're at num1 equals -1, but we're not done yet because we need it to equal 0. So now we choose I equals 0. So once again, now this I becomes 0. So, and subtract 2 to the 0 power plus -2 from 1. So anything to the 0 power is going to be 1. So now we're doing -1 minus 1 plus -2. So 1 plus -2 is going to give us -1. So -1 plus -1 is going to give us 0, right? So when you subtract a negative from a negative, it's like you add it, right? So that's why -1 minus -1 is going to equal 0. Or excuse me, -1, yeah, that's right. -1 minus -1 is going to equal 0. Boom. So it's then now we have num1 is equal to 0. Boom, that took 3 operations. It says it can be proven that 3 is the minimum number of operations that we need to perform. So that's how that question works. Now let's take a look at example 2, where it's a case where it might be impossible to get num1 to 0. So in this case, we have input equals num1 equals our input num1 equals 5 and num2 equals 7. Our output is -1. Explanation says it can be proven that it is impossible to make 5 equal to 0 with the given operation. So since it's impossible to make this 5 equal to 0 with the operations that they give us up here, these requirements, then we just return -1. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult, nor is it that long. So let's get into it. Now, the first thing we're going to do is we're going to try the values of k from 1 up to 60, which is comes from this right here. So we have to pick numbers from 0 up to 60. So for that, we're going to say for K in 1 dot 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 60. Boom. Then we're going to open up the brackets and we're going to compute the remaining value after subtracting K times num2 from nums1. So we're going to say let target equal num1 minus K times num2, just like that. Now, if the remaining value is smaller than K, that means that it is impossible to distribute it across K positive integers, and each must be at least 1. So we're going to say if target is less than K, then we're going to open up the bracket and we could just say return -1. Boom, just like that. Now we're going to check if the number of set bits in target is less than or equal to K. So the non-zero bit count is going to be how many ones are in the binary representation of target, and if true, we can represent target as a sum of K powers of 2. So we just come right here and we say if K is greater than or equal to target dot non-zero bit count, sorry, should be capital B, bit and capital C, bit count, boom, then we open up the brackets and we could just say return K. Then if no valid K is found up to 60, then we can return -1. So we could just come right here and say return -1. That's all the code, y'all. That's all she wrote. Let's give it a run. Make sure it runs correctly before we submit it. It's accepted, so let's go ahead and submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.